going to look at how to describe the different types of distribution that we will see. So there are some standard vocab that we use in order to describe what our data looks like and what it means. So the first thing we always look at is the center of the data. So being able to identify where this is located, if it's in the middle of a data spread or if it's skewed, a term we're going to learn later. So center is where we're at the halfway point between our data. The next we look at is the spread of the data. So when it says the spread of the data, we're just referencing whether it's spread out over a lot of numbers or if it's tight and close together, all of our data entries. So for example, a question might be asked, which one has more spread out of the data shown? So looking at these two, our data here is split between 2.5 and 7.5, whereas here it's between 1 and 9. So here our data is more spread out. So we would describe this as having more spread. So it's not very complicated. It's very just true to the way the language is saying it. Which one has more spread? The one that is literally more spread out. Here is where we're going to see most of our vocab come from, and this is describing the shape of the distribution. So when we're talking about the shape, there's a lot of different descriptors. So the first one would be, where is our center? Is this going to be a symmetric graph where it's the same on either side? Or is my graph going to be skewed some way? And so skewed just means that our data, there's most of it in one area, and then it kind of trickles out to the side for some numbers. So here we would describe this one as symmetric because it is perfect on either side. Now, even if it wasn't exactly perfectly lined up, if the majority of the data is taking this shape, you would describe it as almost symmetric. We would still use that language, even if it wasn't quite perfect. Now here you can see that our data is skewed. So instead of being a nice, pretty shape of symmetry, most of our data, like I mentioned, is to the left, and then we see that we just trickle off to the right. So we would describe this as being skewed to the right. So the majority of our data is here, but there's a little bit of data that was thrown in. These typically kind of are starting to look into something called outliers. This data is kind of throwing it off to the right. Now here it's the same idea. This would be called skewed left. Now we do have a specific name for this area that skews it, and that is called the tail. So whichever way the tail is going, that's the direction it's skewed. So the tail is on the left, skewed left, on the right, skewed right. Then we have this kind of odd shape right here where we just so happen to have the same answer for every single data entry, which is very rare. And so what we say here is this graph is uniform because that's what it means when something is the same all the way across, it's in uniform. So uniform graph here. Okay, so here, this graph, yes, it looks kind of weird, but we're still talking about the shape. And if you look at it, it's doing the same thing on either side. So this is our center, right? The middle of our data. It goes up, up, down, down the same amounts, which means it is actually symmetric because it's doing the same thing on each side of the center. Here we see that this is not symmetric. It does go up on either side, but not even close to the same degree. So this couldn't even be described as symmetric. So if you look at the overall shape, and sometimes I like to say that tracing your graph helps. If you kind of connect all the dots, so to speak, it looks like one of these shapes where most of our data is on one side and then it's trickling to the right. So even though it's not perfectly trickling to the right, we do see that it is still doing that. So again, we're going to call this skewed right. And again, one thing that could help is tracing this to kind of see the overall shape. Now, another way we will describe this is by the number of modes that it has. So remember, mode is the most occurring number. So if I'm looking at this data, I might not have it labeled what my most occurring is, but I see that whatever this is right here, this is the most occurring, and I only have one of them. So if I only have one mode, we use the word uni to describe that. Uni is a prefix for one, so unimodal. This one right here, same thing. I only have one bar that is at the highest, so this is unimodal. Here, same idea. I only have one highest number, so this is unimodal. Since this is uniform, every number occurs the most, so we don't have a descriptor for it. The uniform kind of uses that. And then here, when we have two numbers, so if you look, these two are the exact same height, which means both of these occur the most. Instead of saying unimodal, because there's more than one, there's two, we call it bimodal. So we just use the prefix for two. And then here, yes, we do have what you would kind of see as two different peaks, but I only have one of them occurring the most, so this would be unimodal as well. So for each of these, we describe the shape, and part of describing the shape is also telling how many numbers occur the most. So you'll always have two descriptors for that. Last, we're going to look at unique features. So unique features refer to gaps and outliers. So for example, on this example here, we have something that we would describe as almost symmetric. So that means it's the same on either side. It's bimodal. So if I was describing this to somebody, they would understand that it's going to have the same shape and there's two peaks at the same height. But then I have this gap in data, and I would want to be able to explain that as well. So you just describe it as having a gap. Now here, we would describe this as skewed. And again, remember, tracing your data can help. So we see that it is very much skewed to the right direction. It is unimodal because there's one number that occurs the most. I have a huge gap here. And because I have a huge gap and only one item really over on this right-hand side, I have an outlier because of that gap. So you wouldn't even really need to say gap. Having an outlier is kind of indicative of having a gap, but you can write both of them. We have a gap that results in an outlier. So looking at our data, so this right here is a dot plot, but this is the same concept. We can describe the shape, we can describe the features, and also answer some questions. So for example, it's asking how many participants were represented in the dot plot. So we would just count how many dots there are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 participants surveyed in this dot plot. Out of those participants, we want to see how many earned 10 or more medals. So 10 or more is here, so that would only be 2. And then this is our new stuff from today. Describe the shape and unusual features. So as I mentioned, when it's not super clear, it does help to trace the peaks of your data. And so what we see is the bulk of our data is not in the middle. Our center is over here, and it kind of trails off to the right. So we would say skewed right. I'm looking for how many peaks I have, and I only have one main peak, so we would describe this as unimodal. And then I have these gaps, but because this one is way out here and I have two huge gaps between, even though I have a little bit of data here, I have still these two huge gaps. 14 would be considered an outlier. So I'm going to say outlier, and that kind of also explains that there are some gaps. Okay, so we are going to look at one more with the histogram, the same idea. Now, this histogram is actually labeled at the bottom, so we can answer some questions as well. So, for example, how many participants are represented here in this histogram? So, as a reminder, the number of answers are on the left. So, each block has its own number. So, for this one, it's 9. This one is 7. We have 4 people for this block, 3 and 2. So, this is 5, 9. And then 16, and then 25. So just adding it all together, we have 25 total. How many participants played video games for 10 or less hours? So in this histogram, we have these blocks of 0 to 5, 5 to 10. So if this is 10, 5 to 10 block, we're looking at everyone who played 10 or less. So everything below the 10 marker, that would be 5 people. Now, describing the shape. This is clearly not symmetric. It is skewed in the left direction, right? So remember, wherever the tail is, that's where it's skewed. And then we would describe this as unimodal because there was only one answer that had 9. Everything else was less than 9, so unimodal. So that's it. We're going to pause here. We'll start off by answering the other two together as a group in class.